Alright, this video and Edpuzzle will serve as a review for your CDB coming up this week. We will review some of the topics that you've learned so far this year, and then tomorrow you will continue to review in order to recall what we've already covered. Alright, the first review we're going to do is over similar figures. This was a more recent topic, and we're going to take a look at two problems together before you have to answer one on your own. So with similar figures, there's a relationship, a proportional relationship between what are called their corresponding sides. So in order for me to be able to figure out x, I'm going to have to find the corresponding sides and set up a proportion. So I'm going to start by redrawing one of these shapes so that they are in the same position. That's going to make it a little bit easier for me to notice the corresponding sides. So I redrew the big shape, and since I already kind of highlighted X with red, I'm going to highlight that side. Notice it's longer than the other side I know at the bottom. So the longer side on the original trapezoid, the larger one, would have been 15. So I'm going to label that 15. Okay, then I'm going to go back to the small shape, the one that I didn't change positions. I'm going to notice that other side I have information about is a 3, and it would correspond with this shorter side here, which in the original picture was 4.5. So because this is a proportional relationship, I can use a proportion to help me solve this problem. Alright, so I'm going to go ahead and set up my proportion now. Noticing that if I need x corresponded to 15, so I'm going to put those together across the top. And I'm also going to see that x was in the same trapezoid as 3. So they need to be in the same ratio, and 4.5 corresponded to 3. And then we solve either using a scale factor, or we can cross multiply. Like in this case, I think I'm going to cross multiply and divide. Okay, so 15 times 3 would be 45, and then I need to divide that by 4.5. Got to make sure, since I have that decimal on the outside, that I move it once to make a whole number, and if I'm moving that decimal, I'm going to have to move the decimal on 45, making it 450. So I'm really dividing 450 by 45, and you can see that's actually a much easier problem because now I know 45 goes into 45 once with a 0 remainder. Got to drop that 0. 45 goes into 0 times. So x in this case would have to be, oops, as I almost write the wrong answer, 10. And we can see that that's a reasonable answer. Because it's supposed to be larger than 3, right? This side is larger than that, so it needs to be larger than 3, but definitely less than 15, so 10 is a reasonable number. Alright, here's another similar figures problem. It involves two overlapping triangles. So I'm not going to solve this problem all the way through now that you've seen a similar figures problem. I'm just going to help you think about the best way to solve it. I would again separate my triangles or redraw them as two separate triangles so I can get the best information. I can see that the side length on my smaller triangle here is 18, and here would be 20. Right, if I just isolate that smaller triangle and think about just that. Okay, but on the larger triangle, I can see that this side would have to be 18 plus 9, because I'd have to put those two pieces together. And 18 plus 9 would be 27. So the length of that piece of the triangle is actually 27, and the other side is x. Okay, and then you would set up your proportion from there once you are sure about those side lengths and which triangle is which. If I start with x again, I can see that x would correspond to 20. So I want to make sure 20 goes across from it. Okay, and then I'm going to notice that 18, well, I'm sorry, I should go back to the one with x, because x and this would have to be in the same triangle. So x and 27 would be in the same triangle, which means 18 would go here. And then again, I have the same options. I can look for a scale factor, or I cross multiply to solve it. But when we have these overlapping shapes, one of the biggest reasons to make sure you redraw it is so that you notice these kind of things where you got to put the two sides together and make sure that number is what ends up in your proportion. And again, paying attention to corresponding sides. Alright, now's your chance to answer this question. Find the value of x if these are similar shapes. Alright, so this would be the next problem. You again have similar triangles and are trying to find that missing value of x. Alright, the next review we're going to look at is our constant rate of change review. And so I'm looking at a star-like question here. Could also be a CDB-like question. And I'm going to think through the information that they gave me and use it to figure out which answer choice has the same constant rate of change. So this says which answer choice represents a person burning 90 calories by climbing 18 flights of stairs. Okay, so that's the rate of change that we're being given to start the whole thing. And when we're thinking about constant rate of change, that means that it's changing the same amount each time. But one of the big things we talked about in this unit is rate of change should be y over x, or your dependent variable over your independent variable. So here's a couple of reminders. When I'm looking at a table, it would be x on the left, y on the right. When I'm looking at a graph, the x-axis, which they liked to try and confuse you here and labeled it differently, but your x-axis always runs horizontally side to side, and your y-axis always runs up and down. So even though they're using different variables, we should know where those x and y variables belong. So in this case, we can see in both the table and the graph that y, here we're using the letter C for y, and f is standing in place of x. So that would be for calories versus flights. So if I need to know what y over x is, I'm going to do 90, oops, let me get my pen back, 90 divided by 18. And so I can just simplify this. It might help me out a little bit. So I know they're both going to be divisible by 9. Okay, so that's 10, right? 90 divided by 9, 18 divided by 9 is 2. Oh, look at that. And I know that 10 divided by 2 is 5. So really what I have here is a constant rate of change of 5 calories for each flight of stairs, or for one flight of stairs. That's what the rate of change is really telling us. Sorry, that's the word flight, even though it didn't want to write it all the way. So when I'm looking at these other answer choices, I need to be paying attention and going back to, okay, is it the same as 5 calories for one flight? And if I look here, 1 times 5 is 5. That checks out. 3 times 5 is 15. 5 times 5 is 25, and 7 times 5 is 35. So A actually looks like it's going to be the answer. Let's see if we can figure out why the other ones are wrong. Here, if I look at the very first point, it says for one flight, which is what I have here in my constant rate of change, I should only have 5 calories. Well, this says 18, so that's why C's out. That one's saying 18 calories for every flight of stairs. In our answer choice B, it says C equals F plus 5. Well, that means for every one flight, I should add 5 calories, and I would get, I would add 5 to it, and I would get the number of calories. So for 2 flights, 2 plus 5 would be 7. And we know that's not right either, because each flight, for every one flight, it's going up 5. So by 2 flights, I should already be at 10. This is not an additive process that we're talking about. If we're doing 90 calories in 18 flights, it's multiplicative. We should be multiplying, not adding. So B's out as well. And then what's wrong with D, you might ask? Well, they have it backwards, right? We said 5 calories. They said 5 flights for 1 calorie. So they just switched those variables, and there's always probably going to be an answer choice like that. So we got to take our time and read. Turns out A was the only one that was true. So here's your opportunity with a similar problem to go ahead and find the answer choice that matches the rate of change given in the problem. In this particular question, it's also a constant rate of change problem. So Delaney ordered 4 bouquets of tulips from a flower shop. Her order contained 60 total, sorry, there's something in my way, total tulips for each bouquet. And they contain the same number of tulips. Which table or equation represents the relationship between the number of bouquets, B, and the total number of tulips? It says select 2 correct answers. So let's start with the equations. Decide from what information you were given, your rate of change, which equation, and I'll go ahead and label them, A, B, or C, matches the situation. All right, now that you've had a chance to do that, let's think about these tables. I'll go ahead and label them D, E, and F. So the equation actually is the best way to start because it should help you select the right table. All right, now that we've had some time to review constant rate of change, we're going to take a look at linear relationships and review those as well. All right, so Nicholas is buying shirts for his baseball team. He will pay $9.50 for each shirt, plus a one-time fee of $22.50. When we were looking at linear relationships, we spent a lot of time on how to translate them. And so we started with kind of like a training equation that looked like this. And so we were meant to find 2 things. We had to find what was called the coefficient or the rate of change. And that's always going to be multiplied by x. It's something that's happening over and over again. So we were looking for some rate of change words like each, every, per, a, and the other thing we were looking for is the constant. And a constant only is going to happen once. It's a group of ones that's either being added or subtracted to the situation, but it's only going to happen one time. So a couple of things I noticed when I was reading. I saw this word each, right? So $9.50 for each shirt. Okay, that's happening over and over again every time they buy a shirt for the baseball team. Every shirt costs $9.50. So you hear me using that other rate of change word. I also noticed there's a one-time fee of $22.50 for the design. So they only have to pay for the design one time. And then, of course, a keyword that is up here between the two, plus. Okay, and not always will it have that spelled out for you that we should be adding, but it is nice that they did this time, but you want to be paying attention to, is that constant, that one-time fee or one-time whatever it may be number, is it being added or subtracted? Is it increasing or decreasing the situation? So now I just take those. I know I'm going to have a plus here. And so I go back and I'm like, okay, well, y equals, and y in this case is the total cost. They told me right here in the question. So to get the total cost, I'm going to take my $9.50 per shirt. Now here's the other part. X has to go with the $9.50 because X is standing in place of the number of shirts. We don't know how many they're buying, but they can change the number. They just need to multiply it by $9.50. And then, of course, we've got our one-time fee of the $22.50 that has to be added, because they're not going to let you buy the shirts unless you pay for your fee, your logo. Pay the fee for your design or logo. So you'll notice that my answer, my equation that I translated, looks like answer choice F, right? It looks like it, but a couple of things are missing, like the 0 on the $9.50. And oh, sorry, I lost my 0 there. I don't know where it went. But that's okay, because those zeros, since they're behind the decimal point, they're not necessary. We use them when we talk about money, because money always goes to the hundreds place. But F definitely has the operations we want and the coefficient and constant we want in the right places. Alright, it's your turn to translate this situation into an equation. Alright, so here's another linear relationship. I'm going to go ahead and read it to you, but you're in charge then of finding the best graph to represent the situation. And so kind of thinking through what's happening in the scenario. So Nicole had a collection of 60 stuffed animals. She gave away 5 stuffed animals per month until her stuffed animals were gone. You could definitely just think it through, eliminate your answer choices that are definitely wrong. You also have the option of transcribing an equation, just like we did on the last 2 problems. That might help you as well, especially it'll help you create a table of points. Remember, if you're going to create your own table of points, you get to pick the X's, right? You get to pick those numbers and then use your equation to fill in the Y's. But you would definitely want to pick the X's that you see here on your X-axes. So like 0, 2, 4, 6, 8, if that's the route you choose to go. But there's a lot of ways to approach this problem, so think it through. Think about what's happening. If there's any reason why you can eliminate a couple of answers to help yourself out. Then make sure you select the answer choice you believe it to be. Alright, so now we're going to go ahead and review solving equations. An equation is modeled below. This is how we started solving equations before we did it without. I will say, some of you might find it easier to write the equation out. This is 5x. See how there are 5 x's there? All the ones on that same side are positive, so it would be 5x plus 6 equals 1. And then you have the option of either just solving the equation as you see it, or you could solve the model. I'm going to go ahead and solve this one with the model. So the first thing I need to do is isolate my x's, or get rid of the constant. And so since there are these 6 positive ones over here, I need to bring in 6 negative ones to get rid of them. So I'm just bringing in negatives to cancel those out. But anything I do to one side, I have to do to the other. So since I brought in 6 negatives on the left, I'm going to have to bring in 6 negatives on the right. Let me draw a line through here. Just make it a little more obvious which side is which. Alright, so now I'm going to go back and I'm going to cancel out those 0 pairs, right? This cancels with this. Do it a little faster so you can watch. Every time I cancel out a positive, I'm canceling out a negative because they actually are canceling each other out. So now what my new equation would be is 5x equals, now I gotta go the other side. Are there any 0 pairs I can make over there? Well, yeah, this is a positive 1 and a negative 1. So what do I have left now? Oh, I have negative 5. Okay. So then my job is to figure out what x each of the x's would be. And so if I'm using the model, the way I think about it is each of these would be in its own group. So I need 5 equal groups. And if I'm going to make 5 equal groups on the right, each of these would be in their own group. So that's the same as dividing 5x and negative 5 each by 5 itself. I made 5 equal groups. So now I can see that x equals each of those groups would have a negative 1. So x is equal to negative 1. Alright, so go ahead and solve using the model that is represented here, or if you want to write out the equation you see modeled and then solve that, that's your option. But make sure that when you finish, you pick from the answer choices over here. It's got to be one of those. Alright, here is another solving equations with a model. You're going to type in your solution this time. Alright, solving inequalities, our last review of the Ed puzzle. You have some steps over here on the right to help you. I'm going to use them to help me. So the first thing I want to do is circle my inequality symbol. So in this case I have less than or equal to. Then I'm going to draw a line down just like we would with equations, where anything we do to one side we're going to do to the other. But I need to check on my coefficient, because with inequalities there's that special step. Is my coefficient positive? And you'll notice that the negative 4 that's with x is not positive. So when I follow this arrow to answer the question, no, it's not positive, I have to actually change that inequality symbol around. It is not going to stay less than or equal to. It needs to become a greater than or equal to. So after I made that decision, then I'm going to go back and solve this inequality just like I would an equation, which is good news because we just did that on the last problem. Alright, so now that I know what my inequality symbol should end up being, I've got to isolate my x's by adding or subtracting to get rid of the constant. And in this case, because that's negative 10 or minus 10, I'm going to have to add in 10 positives to get rid of it. The negative 10 and the positive 10 cancel out. I'm going to bring down my negative 4x since that's the only thing left now on that side. And the other side says 2 plus 10, which is 12. So now I need to divide, since negative 4 is being multiplied by x. I do the opposite and divide both sides by negative 4. A negative divided by a negative would be positive, so on the left I get my x just like I wanted. A positive divided by a negative is negative, and 12 divided by 4 is 3. So x should be greater than or equal to negative 3. I already took care of that symbol at the beginning, so I know it's correct. Alright, let's take a look at another one. I'm going to follow those same steps. Actually, let me zoom out for that part so you can see the same steps we were using earlier. I'm going to start by circling my inequality, drawing a line down. Alright, and then I'm asking myself about the coefficient again. I need to know if the coefficient is positive. Is the coefficient positive? Yes. So we just write the same symbol. Going to stay a greater than for this answer. And now I'm solving again, so I'm going to go ahead and zoom in while I solve so you can follow along. 8x plus 6 is greater than negative 16. I'm going to get rid of my constant, that extra group of ones here. Since it was plus 6, I do the opposite and subtract, or minus 6. Those cancel, bring down my 8x. And now I've got a negative 16 and a negative 6. So all of those are negatives. Nothing's canceling. They're all going to stay negatives. There's no positives to cancel them out. So 16 and 6 together would give me a total of 22. And then I would divide both sides by 8. Okay. And this is going to get me my x by itself. So x is greater than, and I know that a negative divided by a positive is a negative. And then I'm just going to have to divide my 22 by 8. 8's not going to go into 2, but it'll go into 22 2 times. That's 16. And 22 minus 16 will leave me with 6. Put a decimal and a 0. Now I need to know 8 into 60. That'll go 7 times, which is 56. Leave me with a 4. Bring down another 0. And 8 goes into 40 5 times. So x is greater than negative 2.75. And that's my solution. All right, so here's your final problem. Go ahead and solve the inequality and type in your solution.